we are given a system of equations x minus y plus 2z equals 2, x minus y plus 3z equals 8. In this system of equations, we have two equations but three unknowns. If you have more than one solution, then write your solution in terms of x variable. So let us make the augmented matrix of this system. So you know that your augmented matrix form will be 1, negative 1, 2, 2. And then you have 1, negative 1, 3, 8. So as you know that I want to keep 1 in here, and then this element needs to be 0. Just below the first row, the first element should be 0. That's the form of Gauss-Jordan method. So what we do, let me call this one is my R1 row, this is my R2. Since I want this element equals 0, so we preserve our first row, 1, negative 1, 2, 2. That means my R1 prime is R1. Now my R2 becomes R2 minus R1, I mean R1, R2 prime. So if you do that, that means your R2 is 1, negative 1, 3, 8, and minus 1 times R1 will be negative 1, 1, 2 negative, and then 2 negative in here. So when you simplify, add them, you get a 0 here, 0 here, 1 here, and 6 here. So that means I'm getting 0, 0, 1, 6. So we have reached to our final version because we have nothing to do after this. Now you can see from the last row that you have 0 times x plus 0 times y plus 1 times z is 6. That means you got z equals 6. From the first row, you get x minus y plus 2z equals 2. So that means x minus y plus z is 6, so 2 times 6 is 12 equals 2. Further, if you solve, then you get x minus y equals negative 10. So then you can say that your y, if you move on the other side, you get x plus 10 equals y. And we already have z equals 6. Because I want to write my solution in terms of x because we have infinitely many solutions. Now when you are writing solution, it will be like x, y, z equals, first is your x, then your y is x plus 10, and z is 6. So you are done.